So thank you very much for everybody joining us. Welcome to today's webinar, Moldex 3D, presented by John Hughes, PDSVISION. So everybody's on mute. We're going to go through some slides, some introduction, then get into the demo. We'll have some time at the end for Q&A. Let me make sure I'm hitting record. Perfect. So objective today is to review and demonstrate Moldex 3D. We'll have an introduction. We'll cover briefly digital thread. Our topic overview is Moldex 3D and why use Moldex 3D, what you need, followed by some question Q&A, and then we'll wrap up the webinar. So again, thank you for your taking time out of your day to join us. So my name's John Hughes. I'm a technical specialist with PDSVISION. I've been here for a little over 2 years. My background is 25 plus years in product design utilizing PTC products, primarily Creo, as well as some other CAD software. 20 plus years, mostly plastic application design and development for injection molding, design, and simulation. Introduction to PDSVISION, formerly Boundary Systems, which a lot of you are familiar with. We're a technology leader, first PTC global reseller and preferred service provider, software solutions developer for design and manufacturing. Our capabilities are in consulting, implementation services, professional training, cloud, and our help desk. Here's a little background below on Boundary Systems. Started early 2006, and then PDSVISION in early 2008. And we joined forces starting in early 2018 to make us truly a global company. So introduction continued, our strategic partners and solutions, of course, to PTC and Moldex 3D, which we will cover today, as well as some other partners and solutions. So the digital thread. So the digital thread connects the whole engineering and manufacturing process. It's defined as a communication network that enables a connected flow of data, as well as an integrated view of an asset's data across its lifetime through various isolated functional perspectives. So basically, this concept promotes transmission of the correct information to the correct place and the correct people at the correct time. Here's another picture of the digital thread by department. Now, moving into the webinar topic. So Moldex 3D is the world-leading CAE product for the plastics injection molding industry. So with best-in-class analysis technology, Moldex can help you simulate the widest application range of injection molding processes to optimize the product design, the manufacturability, the processing, shorten time to market, and of course, maximize your ROI, return on investment. So why use Moldex 3D? Again, it's a best-in-class analysis tool to let you evaluate moldability before a mold is designed, and even better yet, constructed. So Moldex 3D can predict and help you avoid potential molding defects, reduce gap between real part and simulation, so help you to take the guesswork out of the design stages. So again, avoiding defects, and in this case, reducing time to market. We can optimize the molding process through simulation early on throughout the process. And here, best used early on and throughout your design process, before, during, and even after the mold design has been completed and constructed. Continuing, Moldex 3D can be used to evaluate gating requirements, so quantity, number of gates, and locations. To evaluate the mold layout design with melt delivery systems. I mean, we might have a multi-cavity, a family tool. And the strength of Moldex 3D is it has 8,000 plus materials in its database, as well as you're going through the design process, you can use the Moldex 3D to identify potential problems, but then not only that, make software, go through the process again to evaluate, update your model and evaluate it to make sure that it's going to give you the most robust part design and processing and manufacturability before you've spent any money on cutting any steel. So with that said, we will move right into our product demonstration. So again, let me start this over. We're going to exit this out. Close window. Oop, yep. So it's a simple. Wherever you have your Moldex 3D Studio installed, I've got a shortcut on my desktop. So we can launch Moldex 3D just as the same way you'd launch any other CAD software. By default, it opens up. It's assuming this is a clean slate. So the process would be to start we have an option of starting a new project or opening a project. If we start a new project, our specified file name and location pops up. So we can customize this file name as needed. We can specify the location where we would want that file folder, that Moldex simulation to store and run. So if we just this, apologies for the background noise. So I've just accepted the default. Like I said, we can customize the name. We can specify the file location. Once we do this, it starts by default with a run 01. And if we look at the ribbon, we have it, everything moves left to right. So here we have the options of adding additional runs, or if we expand this, we can add a run, we can copy a run, we can import runs from other simulation that you might have already run. Again, moving left to right, next to new run is our injection molding or our molding type. If we expand the molding type, by default, it's injection molding, but we have these other molding type options that Moldex 3D can be used to evaluate. We are going to stay with injection molding. And then again, moving to the right, we have importing geometry. So we can import geometry. We can import geometry auto heal, which in the event that you have any defects, the auto heal can resolve the majority of them, if not all of them. It's a good practice though, depending on whatever CAD software you are using, to make sure that if your file is a nice, robust, solid, closed, watertight, solid, best thing to do is, if you export your step or parasolid files, which Moldex 3D can read step, parasolid, as well as other formats, including native. And in this case, I'm working in Creo 7060. But it's a good practice to, when you're working your native files, any file formats you're exporting, bring back into that software to make sure that those are clean solids, no errors. This is just good practice to ensure that there are no, if there's a problem in your native software, there's potentially going to be a problem in Moldex 3D. So in this case, we're going to start importing geometry. Now I've taken the liberty of extracting from a tool design all the appropriate stuff. So we've got the part that we're going to be evaluating. I have various datum curves on here that represent the melt delivery system, water lines, core and cavity side. So again, this is a good practice to go through in your CAD model, either develop or extract the data that you need from the tool, and then format it here. So we'll minimize this. So again, I mentioned that importing, it can read step, part files, various different file types. I've got step versions as well as the native Creo part files here that I'm going to be using. We can import, I'm just going to import this as all to go through and show. So again, a part file, you have to decide whether or not if it's a native NX or Creo. This is Creo in this case. We'll import the model. So it is reading the file. This usually takes less than a minute. It'll do some reading, checking, and converting. This is importing all of that geometry you saw in the Creo, which was the part solid and the datum curves for the various melt delivery system and cooling channels. So we import this file. We can look in here if we want. We see all of the data that was imported. Next thing to do would be to check geometry. So check geometry, it's going to check again and make sure that you don't have any issues with the model. Free edges, tiny edges, these are usually areas that it's going to cause a problem for meshing. Now, in the event that there are some issues and you have a CAD Doctor, which is a powerful extension that can be added to help you resolve any import issues or model issues within the Moldex 3D. We can select the CAD Doctor. CAD Doctor will import and launch. So it's imported the model. We need to run a check so we can check the model. So this is finding 18 minor errors. Usually minor errors are not an issue. Anything that is considered critical would need to be addressed. If there were errors, major errors, and even regardless in this, we can hit the auto heal. Again, it still has some minor errors, but this is acceptable. We can export this back from CAD Doctor back into the Moldex 3D. We can exit here. The next step, again, moving left to right, we've imported the model, we've checked the model. Now it doesn't know, Moldex doesn't know what this geometry is. So we can select on the part model. We can select attribute in the ribbon or right click in the window, and our attribute wizard pops up. And looking at the attribute wizard options, so by default it's none. It hasn't been assigned yet. We've got parts, part insert, cold runner, hot runner, mold insert, injection unit, mold base, mold plate, cooling channel, heating rod, overflow, encapsulation component. In this case, this is a part. We're going to assign the part attribute, select the check. Again, now as we selected and assigned an attribute to this, we can go and check out the model thickness. Now, just for clarity here, I'm going to go through and I'm going to turn off. Well, we see now that I have a part that's been attributed. I've got all this other geometry that is cluttering up. I can hide this for now. Go back, we can hit and evaluate the model thickness. So this is going to run a mesh over the part as is. and it's going to allow us to evaluate to make sure part, especially when we're talking plastic injection molding, we want as uniform of a wall thickness on the side. We can scale down to evaluate our model thickness, and for the most part, this part is pretty uniform wall thickness. There might be a couple of areas where it's a little thinner, thicker, and this is a good tool, a quick tool to use, especially if it's something that was missed in the design process. We can go back in and then tell the designer or ourselves as a designer to address the areas that may be violating our uniform wall thickness policy. Back to home. So we've imported this geometry. I've gone through and we've shown. So to get back out of that, we can just go and select the model. Now we have a bunch of other geometry here that's critical for setting up our Moldex 3D simulation. But a good practice would be to import all this geometry individually in sequence, assign the attributes, and then go forward. So I'm going to go through this process. I'm going to delete all of this added imported data. So we have our part that we imported. We assign the import attribute. We're going to go in now and import. Again, I've done my due diligence up front. I've gone up and established or created all of the data that I need. We're going to import the melt delivery system from the Creo part file. So we see these attributes. If we want, we can hide the part or leave it open. Now I'm going to start from the cold runner system, and I have actually also doing some due diligence up front. I've created some cheat sheet images of my melt delivery system. So roughly my cold runner system, I'm going to go and build this using the datum curves that are in here. I'm going to move this off screen for now. So we have our cold runner system. We would select the appropriate datum curves. Okay, so here's something too. In the event that you import additional curves, we can select out and we can select and delete, because we really only want one set of curves. We could have done this, or it could have signed properties and taken care of it otherwise, but yes, the functionality within Moldex 3D is if it does not come in perfect, you have the capabilities of addressing it within the Moldex 3D. So I'm gonna go back in, assign these properties with Cold Runner, try and get through this as quickly as possible just to show the speed and the power. So edit attribute or assign attributes, Cold Runner. This is a straight bore of 9.5 millimeters. I am going to hide the part, zoom in. We're going to assign the gate. Again, nothing too complex. Okay, so there are no additional lines there. That's great. Right click, assign attributes. This is going to be a cold runner gate. In the cold runner gate options, we have pin gate, sprue gate, edge gate, fan gate, lapped edge gate, tunnel gate, and cashew gate. So all this can be done utilizing the datum curves that you create and import from your native CAD. This is going to be an edge gate. Now, the red dot and green dot indicates kind of the starting points. You may find out that we've got the red dot on these runners is at the runner. So I'm going to go through. We will fix that. It's very easy to fix later. So let's see the height, 4.5. The width on this, we're going to call it 9. Our gate at the part is 1.75 thick. This was extracted from the model, but the nice thing about this is when you're doing this, even if you don't have the tool designed, you can go in and do your layouts and evaluate different gate sizes and runner systems through this process. As we see here that the gates here are what we want, this end as well. These two in the middle are off. We can hit the check to accept. And then we can go in and select individual gates or runners or anything that's attributed, did not attribute the way we intended. Right click, edit attribute. So we can just switch these dimensions, 1.75, 4.5, 4.9. That looks a little bit better. Hit accept. Now we might want to show our part again. It's getting a little cluttered, but still. Now we're going to quickly, as quickly as possible, select an attribute. And again, this is a little bit more complex of a part, but I wanted to show something that had a lot more complexity than just showing a simple model. For purposes that, yeah, we'll just keep that at 10. Now, it's best when you're attributing geometry or curves to assign the attributes to the straight bores. So you select one feature or one datum curve, hit control, and then select your additional curves. So it's intuitive to pick the intersection with other geometry. As we see, we have of the 6, we have 1 that did not update as we intended. We can easily go in and resolve that. Now, so I've got my part, my cold runner portion. This is a 6-drop hot manifold. So I can go through and I can turn off unnecessary geometry that I don't want to see. The primary bore diameters on the hot manifold, we'll assign those. Edit attribute. Hot runner, bore diameter is 15 millimeters. Again, it's helpful to have this information from your CAD model or from, some reference. Again, it doesn't have to, you don't have to have it, but the more data that you go through in the simulation, the more accurate and relevant your results should be. And typically when you have the information all laid out in advance for you, especially you're working in the CAD, you're designing and developing your product, the whole process should take less than a half hour at most, depending on the extent of the type of simulation that you want to process. Again, we might want to show the cold runner. So we've done our straight bores on the hot manifold. Oh, I missed one. Runner 8. Now, anything that's tapered, again, the nice thing about Moldex 3D, we've assigned these attributes. When we go and assign additional attributes, it'll use dimensions. It'll calculate the dimensions we intended. So it assumes the design intent. We are almost done. Thank you for your patience. Okay, so we now have a part, the cold runner system, the melt delivery system, all attributed. We could go forward now as well as importing other geometry. We're going to import our cooling channels, our water lines. We'll do with the core first. Again, so that imports, so since I imported a step, this imported a little quicker. So we can definitely import step files. If I want, I can hide everything. Go down now to the non-attributed. So again, this is doing this kind of in sequence so you don't have too much stuff going on. We can select, again, we can select individually or we can group select with a box. From left to right, anything contained within the dash lines will be selected. If you go right to left or anything left to right dash touches is selected. Left to right, anything enclosed can be selected and deleted. Now, so we've got this runner system. We can go ahead, same thing, assign attributes. All of the bore diameters for the water cooling channel. Is 12 millimeters. Cooling channel. I'm just going to show a little bit of this just to go through, and I know that time is of the essence. So we have our cooling channel, and then we have baffles or bubblers. So cooling channel, so we've got a regular bore diameter. We can do baffle or bubbler or hose. So assuming we went through and we assigned all of these attributes, as you saw, this could take a couple of minutes. We could assign the attributes. I'm going to go through and actually do a quick copy run. This is one of the slightly longer topics for a webinar. So again, thank you for your patience and bearing with me. If we go back to run one, and we were to decide that the simulation we were running did not require to do all the cooling layouts, go back in. So we've got our part and our runner system that has been designed. Again, so next step is once you've imported the geometry, you've checked it, we've specified the injection molding type. We can go in here and do a mold base. So again, we don't need to import the mold base from our design, but if you have those dimensions, you can modify these dimensions accordingly. If another good practice in my Creo, I made sure that my part and melt delivery system was established in the proper XYZ coordinate for injection molding as far as at the molding machine, with the positive Z pointing in the direction of your screw and barrel. So this would be your layout in mold position. In the event that your geometry was not oriented in the right XYZ coordinate system, when you do the mold base within here, rather than rotating your geometry, you can easily turn your mold base to represent what it should be or what it would be in molding. This is very helpful, especially, like I said, in the event that oftentimes the part you're working at that you receive the XYZ coordinate system is not what it is for injection molding. It's in application mode. So we are fine with this mold base. Again, if we wanted here, so we've imported the model and the runner system assigned attributes. We could, I should have pointed out, I selected the mold base. Once we did the mold base, our cooling channel is became available to us. So again, if you don't have a cooling channel layout that you're going to use, Moldex 3D has built-in capabilities to create cooling channels here within the model. We can modify the diameter, the number, the spacing. And this is all helpful if you're running Moldex 3D. You do not need cooling channels for a fill and a pack analysis, but if you are doing a warp analysis, it is strongly recommended that you have cooling channels, even if they don't match exactly what's going to be in the end tool. So we can change the height, the spacing. Again, depending on the direction, you have the capabilities of rotating it to the orientation within the model if it's not in the orientation that you intended. So if we were to do this, the next step is once we've done cooling channels, we can do inlets and outlets. Auto fix. So again, if there's something that's not quite right, you have some auto fix options built within. Now the next step would be is to go through, and we've done all of our importing, assigning attributes. And the next thing would be to set up the seating. What we might want to do is turn off some of the geometry. We only want to look at the part. The seating is what's going to determine your mesh size. So by selecting the seating, we selected the part that we want to mesh. Hit accept. It's going to calculate and do a default length on the mesh. A good rule of thumb is to orient it in a flat view to get either the whole single cavity or one cavity if it's a multi-cavity part in there. It's going to choose a default mesh size. We can apply. Now the spacing, what's recommended, the spacing between the nodes or the dots should be no more than 4 dots in between. So this is a little tight mesh. So it's going to be a tighter mesh. It's going to create a tighter mesh, which is going to be more elements, which is going to add a little bit more time to your processing calculation. But in turn, it's going to give you better results. But for filling and packing, it may not be as critical. We can go ahead and specify a higher mesh size and hit the apply. We can see how that updates. We can go even higher. So that might be a little closer. Let's split the difference, go 5, apply. And this is where you typically would just bypass this. We're going to go back in and we're going to show the model again. We've got the mold base. We could then go here through the process of generating the mesh. We select generate, generate. It creates a surface mesh, and then it checks the surface mesh to make sure everything looks good. In the event that you have any issues, we can hit fix and use the fix wizard and cycle through. Oh, that wasn't supposed to happen. So I'm going to launch Moldex 3D again. So you can go through the process of fixing that. And for time's sake, I am going to open up the simulation that was already run. So again, going through the process, typically once you mesh that, and if you have to fix anything, probably could have restarted. Moldex 3D has some built-in tools to adjust the meshing. Sometimes that the mesh size, in that case, that mesh size might have been a little too big. So by refining, making it a tighter mesh, which is going to add more elements, you can go through the meshing process. That will take care of some of the issues, especially if it's small edges. So in this one where I've already got it, I've imported the geometry. And I just wanted to show that this was imported and attributed everything. I went through the Liberty's End of copying the run and going through the meshing process. So I'll show you what the mesh looks like. And typically to mesh that, the parts, the runner melt delivery system, and the cooling channels and the mold base is 3 to 5 minutes. So let me let this open up and I can show you. So this is what the mesh looks like. We've got our mold base. We can turn off some of these things. We're going to turn off the mold base. We have our parts, our cold runner, hot manifold, cooling channels, and bubblers, baffles. We can check the information. So the information on this is 6.7 million elements. With this in, we have the part volume, mold volume, so part cold runner portions, because we brought these in and attributed those. So the next step after, if we would have imported and assigned the attributes, gone through the meshing, our material would have opened up. And we would assign the material. So again, going in through here on the material side, we expand the material. The power of Moldex 3D is in the material wizard within the Moldex 3D data bank. The 8,000 materials plus are listed by family type, and then under family type by manufacturer, and under manufacturer, all of the grades that they have for that material. So again, there's 8,000 materials. Typically, the material that you need to run is in here. The other thing you can do though is typically you can find a very close or identical alternative. And if that case that you can't find the exact grade, I've used in the past, I've used a grade that has slightly better and slightly less processing capabilities, so that I know that somewhere my model is going to be in between. So again, in this case, we'd select the PC Lexan 945. We would go through again, going back to our build. So we've meshed everything, everything's been good. We've selected the material. Next step would be the processing type. So if we expand the processing window, we have our maximum injection pressure that we can set. Typically, it's recommended to set that to 25,000 because we want to make sure that it doesn't indicate a false short shot. If we don't like our units, trying to change units, I can change this from metric to English again, but moving forward, the next step would be is our filling and packing. Moldex 3D will calculate the flow length and the volume and thickness of the parts, and it's pretty accurate on estimating potential fill time. Default's 98% switchover. Packing time, you might want to change. If you need to, we can modify the melt temperature and mold temperature. The cooling settings can be modified. Once that's done, you can save this. I don't have to save this because it's already saved. We would then go, after we've done the selected material, the process, now the analysis type. So within the analysis type, typically, again, early on the process, you're going to do a fill and pack analysis. You may or may not have the cooling channels in there. If you're going to do a fill pack warp, fill pack cool warp, it is recommended that you have the cooling channels in there. If you don't, these options will not be available for you. So moving forward, I went through the process of running a couple analysis. I ran the fill and pack analysis. Let me see if I can show you how long these simulation took. Trying to figure out what screen it's going to. Well, the fill and pack analysis, utilizing 4 cores of my 6 cores, took about 1 hour and 50 minutes. I went through and also processed a fill pack cool warp analysis, and this actually took only an additional, I did use 5 cores. This ended up taking a little over 2 hours. But if we go into the results, Again, so our results are displayed. We can change our graphical display. We can go in and hide unnecessary geometry. We do, of course, want the hot runner and the cold runner system. So under home, we've got our results. We can run through a filling to basically check the filling pattern. And or again, to try and make sure that everything is symmetric and filling is possible. We can check our pressures. There we go. Under our settings, we can change the units from metric to English or English to metric, whatever our preference is. So basically, this is 20,000 PSI. So this can determine if our injection pressures are too high. Is it something we need to do? Is it the gates are too small? Is the wall thickness too thin? Do we need to add more gates because of the flow length? And I can see that I am running quite a bit long, but in our results, we have our filling results, which include weld line, so your melt front pressures, temperatures, shear stresses. You can also expand, let's check the warpage, displacement. We can see the areas that are going to have the greatest risk of warp. Packing pressure requirements, again, so we've run this analysis, we've done everything in, it takes usually less than 30 minutes if you got everything done well in your CAD model. To save time, we can go and do this in the Moldex 3D, import it, assign the attributes, mesh it, assign the material, determine the processing analysis type that we want to run. And then also under computation, we can check estimate required cooling. We can do particle tracers and weld line particle. So again, maybe this was a little bit more extensive of an application to fill. Again, Moldex 3D, very powerful tool that can be used to identify potential problems before they are realized or before they happen. So yeah, Moldex 3D, best-in-class analysis tool. Predict and avoid potential molding defects in advance, reduce gap between real parts and simulation, can help you take the guesswork out of the design stages to avoid defects and reduce time to market, optimize the molding process, best used early and throughout the design process, especially before a mold has been designed and constructed. But also, even when the tool has been designed, it's a good check to make sure that once you have better ideas on, say, that cooling channels, the location, everything, if everything has to be in or where it's at, to rerun the analysis to make sure that it's going to meet your processing requirements. So collaborating with your molding, your process engineers, and the tool builders if needed, if that's something that's outside. But this information you can use in advance, especially before, if you're an OEM or the designer, this can be used to make sure that you've got everything designed as best as possible and present that, and then even use to get consistent quotes or to, again, run through that with your mold designer and your molders, whether they're inside or external. So with that said, any questions? I see a question here. My apologies. For some reason, my screen's a little small. Question regarding, can Moldex 3D run simulations for parts made with blow molding process, specifically extrusion blow molding process? I do not believe so. I am not sure if that is going to be an additional option moving forward. But again, injection molding, sorry, let me go back in. No, so it does not look like the blow molding, extrusion blow molding process is an option at this time. Any further questions? So I will still definitely hold on for any additional questions. If you want to learn more about Moldex 3D or anything else that PDSVISION can do, you know, our webinar topic presenters are all certified trainers, and we can dive deep into each topic. We have trainings available. We can do training for PTC Creo, Windchill, Moldex 3D. We can do virtual or in-center or on-site. Please check our website for a full schedule of training classes, webinars, and hands-on workshops. If you have any further questions or require any further information, my contact information is on the screen, jhughes@pdsvision.us, as well as sales@pdsvision.us. And our PDSVISION, we have a PDSVISION YouTube channel. So again, I'll hold on if there are any further questions. And if not, I appreciate your time. Thank you for taking time out of your day and during lunch, and I hope the information was helpful. And again, please feel free to reach out to us if we can provide additional information or a more specialized demonstration of Moldex 3D, perhaps on your application, so you can see better the benefits. Looks like we have no further questions. I'm going to end the meeting. Thank you very much again for your time. Have a good day.